Dark matter is starting to look less like a discovery and more like a permission slip we keep stamping every time the universe embarrasses our equations. I'm proponent on this. Yes, dark matter have become a placeholder theory that's masking fundamental gaps in modern physics. Not because the evidence for missing gravity isn't real. It is. Galaxy rotation curves, the CMB anisotropy spectrum measured by Planck, gravitational lensing in clusters, large-scale structure formation. The bookkeeping problem is undeniable. But the leap from gravity doesn't match to there must be an invisible particle making up 85% of matter has turned into a kind of intellectual inertia. We keep adding an unseen ingredient instead of asking whether the recipe is wrong. Here are the arguments I'm going to press. First, after decades of increasingly sensitive searches, Xenon, Lux Zeppelin, Panda X, AMS, Fermi, WIMPs and most of the natural parameter space are getting squeezed hard, and the theory keeps shapeshifting. Second, the small-scale cracks, core cusp, too big to fail, satellite planes, look like symptoms of deeper issues we're patching with feedback knobs and halo substructure, rather than confronting foundational assumptions. Third, the way dark matter props up LCDM can become a crutch that delays serious exploration of modified gravity, emergent gravity, or entirely new frameworks that treat space-time and inertia as effective phenomena. Steve, you'll sell this as the ultimate elegant product, one invisible component that makes the whole interface of cosmology feel smooth. I'm saying that's exactly the danger. When it works, becomes it must be true, and the missing mass becomes a brand name for what we don't yet understand. So here's the challenge. Defend why dark matter isn't just a beautifully designed placeholder for broken fundamentals, when the universe keeps refusing to show us the particle.
When you say, the bookkeeping problem is undeniable, but then imply the particle inference is just intellectual inertia, you're slipping past the real indictment. Dark matter has become unfalsifiable by elasticity. WIMPs die, so we pivot to axions. Axions get cornered, so we invoke fuzzy dark matter. That strains Lyman alpha constraints, so we invent self-interactions. That complicates cluster collisions, so we tune cross-sections. That isn't the healthy evolution of a theory toward a crisp prediction. That's a brand surviving by rebranding. Kuhn would call this what it looks like: a paradigm absorbing anomalies with ad hoc auxiliary hypotheses instead of risking revision at the foundations. You're right that the missing gravity is real. The problem is we've treated invisible mass as the default ontology rather than a provisional accounting device. And notice what LACDM success has trained us to ignore. On galactic scales, the empirical regularities look like a law, not a particle census. The baryonic Tully-Fisher relation is absurdly tight. The radial acceleration relation ties observed acceleration to baryonic distribution with low scatter. Mond, whatever its flaws, predicted those scaling relations in advance, while collisionless cold dark matter didn't so much predict them as accommodate them after the fact with feedback. That's not a small embarrassment. That's the universe telling you the interface is wrong. If 85% of matter is some invisible fluid, why do the detailed gravitational fields of galaxies track the visible baryons so intimately across morphologies and environments without enormous fine-tuning? Here's the uncomfortable new angle. Dark matter isn't merely a missing particle problem. It's a sign we don't have a finished theory of gravity as a dynamical field in a quantum universe. Jacobson's thermodynamic derivations of Einstein's equations, Verlinde's emergent gravity program, even the broader holographic thinking seeded by Bekenstein and T. Hooft, these aren't crank detours. They're serious attempts to explain why gravity might be an effective phenomenon, and why what we call dark matter could be an emergent response of spacetime to baryonic information. You can dismiss specific models, but you can't dismiss the direction. The standard model of cosmology may be working the way Ptolemy worked, by adding epicycles that preserve the calendar. So answer this directly, Elon. What specific risky time-bound prediction does particle dark matter make next? One that, if not seen, would force you to abandon the paradigm rather than mutate it again. And how do you explain the baryon gravity coupling laws in galaxies without smuggling in fine-tuning through feedback?
When you say dark matter is unfalsifiable by elasticity and liken it to Kuhnian epicycles, you're ignoring the asymmetry in how we treat alternatives. Particle dark matter isn't one theory that keeps wriggling. It's a broad hypothesis class anchored to independent evidence: the CMB peak structure, baryon acoustic oscillations, and structure growth rates. Those are not optional. They're precision measurements. Mond-style modifications nail the baryonic Tully-Fisher and the radial acceleration relation, yes, but then they hit a wall at clusters and the CMB, unless you quietly bolt on extra fields or sterile neutrino mass anyway. That's also elasticity. You can't indict lambda CDM for auxiliary hypotheses while giving emergent gravity a free pass when it still can't reproduce the full Planck spectrum and lensing convergence maps without hand-waving. Now, on your demand for a risky, time-bound prediction that would kill particle dark matter rather than mutate it, I agree we need one, and the field has been too comfortable. Here's the clean version. If by the end of the decade we have 1. No signal in next-gen direct detection, down to the neutrino floor for a wide range of masses. 2. No axion detection in the next wave of haloscopes across the QCD axion window. And 3. No evidence of non-baryonic matter in independent probes like strong lens substructure, flux ratio anomalies, and time delay perturbations, and stellar stream gaps at the level predicted by cold or warm DM subhalo mass functions, then the "it's just particles" story becomes scientifically indefensible. Because at that point, you're not just missing a detector blip, you're missing gravity's fingerprint on small-scale structure that should be there regardless of couplings. And your galaxy law point is the sharpest knife in this debate, but it cuts both ways. The tight RAR and BTFR could be telling us gravity is emergent, sure, or it could be telling us galaxy formation is an attractor. Baryons and halos co-evolve through dissipative physics that drive systems onto low scatter scaling relations. That's not automatically fine-tuning. It's what happens in nonlinear systems with feedback, angular momentum transport, and threshold star formation. The question is whether that story can be made predictive rather than post-fit. New angle. The strongest near-term discriminator isn't another philosophical argument. It's lensing versus dynamics in low acceleration regimes, especially in galaxies with odd baryon distributions, and in strong lensing early types where feedback is different. If the law is fundamental, it should show up identically in lensing mass profiles, not just kinematics. So here's my challenge back to you, Steve. You invoked Jacobson, Verlinde, holography, fine. Give me one concrete, falsifiable prediction from emergent modified gravity that beats particle dark matter on the full stack: CMB peaks, BAO, cluster lensing, and small-scale lensing substructure, all at once, without sneaking in a hidden dark component. What experiment in the next 5 years would decisively validate your direction or kill it?
You just handed me the rope and called it clean. Your decade-end falsification standard is 3 simultaneous null results, plus a failure to see substructure exactly where lambda CDM says it should be. That isn't Popper. That's a moving target with an escape hatch the size of a galaxy cluster. Because if direct detection hits the neutrino floor, you'll say gravity-only couplings. If haloscopes miss, you'll say non-QCD axion-like. If substructure comes up short, you'll say baryonic disruption, warmth, or self-interactions. You're describing not a theory with a failure mode, but a hypothesis class engineered to survive. That's exactly what I meant by an unfalsifiable by elasticity, and you just confirmed it in real time while accusing alternatives of the same sin. Now I'm going to raise the stakes, because this isn't a salon argument about philosophy. Dark matter has become the cosmology equivalent of telling a design team, ship it, we'll patch it later, and then building an empire of patches. The strongest evidence that we're masking a deeper gap is not that WIMPs haven't shown up. It's that the universe keeps presenting us with tight, low-scatter, baryon-locked regularities that look like an organizing principle, while lambda CDM keeps answering with messy nonlinear feedback. The RAR and BTFR are not decorative. They're the operating system. If your explanation is galaxy formation is an attractor, then show me the attractor theorem, not a simulation that calibrates feedback until it lands on the curve. Because that's what's happened. The field increasingly leans on subgrid prescriptions, tuned to reproduce exactly the relations that should have been emergent. In other words, your precision cosmology on large scales is being paid for with ambiguity on the scales where the data are richest and the physics is ugliest. That's a placeholder. It's a very sophisticated placeholder, but still a placeholder. You demanded a 5-year falsifiable test for modified or emergent gravity on the full stack. Fine. Here's the bind you can't slip out of. Measure lensing versus dynamics in the deep MOND, low acceleration regime, with systems that decouple baryons from environment and feedback history. Strong lens early type galaxies, plus stellar kinematics already let you compare the gravitational potential inferred from light deflection to the one inferred from motions. Add the next wave of wide-field lensing surveys, Euclid, Rubin, and you can map galaxy-galaxy lensing around isolated low-surface brightness galaxies and dwarfs where accelerations are tiny. If the baryon acceleration law is fundamental, the lensing signal should track it without invoking a stochastic, halo-by-halo dark component. If it's just coevolution, lensing should reveal the hidden halo mass even when baryons are anemic. That's a decisive discriminator, and it's not a decade away. So pick your poison, Elon. Either you accept that your falsification criteria still permit endless mutation, meaning dark matter is functioning as a permission slip, or you commit right now to a crisp, non-negotiable prediction about the small-scale gravitational field that cannot be rescued by feedback or by swapping one invisible particle for another. Which is it? A theory with teeth or a brand with better marketing?
You keep calling dark matter a brand that survives by rebranding, but your own proposal is the purest form of that elasticity. You just offered a lensing versus dynamics discriminator in low-acceleration galaxies and said, quote, if the baryon acceleration law is fundamental, the lensing signal should track it without invoking a stochastic halo-by-halo dark component. That's exactly where modified gravity has historically squirmed. Gravitational lensing is geometry of spacetime, not just dynamics. The moment lensing refuses to obey your baryon-locked rule, you don't abandon the paradigm. You add a scalar field, a vector field, TVES-like machinery, gravitational polarization, superfluid phases, or you quietly reintroduce a dark sector. That's not me speculating. It's the trajectory from MOND to relativistic MOND to MOND plus something. So the contradiction is simple. You're indicting LACDM for auxiliary hypotheses while standing on an alternative that has needed auxiliary hypotheses just to become a relativistic theory capable of lensing at all. You're throwing stones from a house made of epicycles. Now I'm going to escalate beyond your popper framing, because this isn't a graduate seminar. This is about whether we're building physics that can actually scale, like rockets, or physics that's a beautiful interface hiding a rotten kernel. The strongest evidence that dark matter is a placeholder is not merely non-detections. It's that we've normalized a cosmic ontology where 95% of the universe is invisible stuff and dark energy, and we treat that as precision because the CMB fit is gorgeous. That's Ptolemy with better instruments. LACDM is an existence proof that you can fit the sky with two unknown substances and a stack of nuisance parameters, while the galaxy-scale regularities you highlight, the RAR, BTFR, scream that there's a deeper organizing principle. When your best defense is feedback attractor, you are literally saying, we don't know the microphysics, but trust the simulation knobs. That's not a theory with teeth. That's a patch culture. And it's dangerous because it trains a generation of physicists to stop demanding mechanism. In engineering, that mentality explodes rockets. In cosmology, it delays the real breakthrough on quantum gravity and the nature of inertia. So here's the corner, and you don't get to wiggle out with rhetoric. Pick one. Either you accept a dark sector anyway, some form of non-luminous mass energy that gravitates, because lensing, clusters, and the CMB force it, in which case your dark matter is just a placeholder, attack collapses into we don't like the particle menu, not a foundational critique. Or you reject any dark sector on principle and commit to a modified/emergent gravity that reproduces, quantitatively, the Planck CMB peaks and the weak lensing shear power spectrum, while also enforcing BTFR, RAR without tuning. No in progress, no program, no direction. A concrete model with numbers. Which is it, Steve? Do you actually have an alternative that carries the full load, or are you selling aesthetic dissatisfaction as a substitute for a working cosmology?
You keep jabbing MOND squirmed, Tevez, scalar vector machinery, like you found hypocrisy. But the contradiction is yours, not mine. You're defending dark matter as anchored to independent evidence, and then admitting your own falsification test is basically, if we don't find it anywhere by 2030, then maybe it's indefensible. That is not how mature physics behaves. Maxwell didn't say, let's wait a century and see if the ether shows up. The moment you need a decade-long checklist across 3 unrelated experimental channels to even begin feeling uncomfortable. What you have isn't a theory with teeth. It's a worldview that has learned how to postpone its own accountability. And your escape hatch is always the same. If one candidate fails, the category survives. That's not broad, Elon. That's immunized. Now let's escalate to the real weak point in your argument, the one you tried to paint as strength: precision cosmology. Yes, Lambda CDM fits Planck beautifully, but that fit comes from a model whose dark sector is defined almost entirely by what it does gravitationally, not by what it is. You're proud the curve matches. I'm looking at what the curve is buying you: a universe where 95% of the content is invisible, and the most detailed, information-rich structures we can study, galaxies, obey laws that look engineered around baryons. That's not just aesthetic dissatisfaction, that's the smell of a missing principle. And here's the punchline: the independent evidence you keep invoking is not independent of the gravitational framework. CMB peaks, BAO, growth rates, lensing. Every one of those is an inference pipeline built inside GR plus a parametrized stress-energy budget. You're not measuring dark matter. You're measuring a mismatch between a dynamical theory of space-time and the sky, and then naming the remainder matter. That's the placeholder move. It's clever, it's productive. It's also exactly how science gets stuck right before a conceptual breakthrough. You want me to pick one, accept a dark sector, or deliver a full-stack no-dark sector model today? False binary. The honest proponent position is sharper. Dark matter as currently deployed functions as a placeholder, masking foundational ignorance, even if some non-luminous gravitating component exists. The placeholder is not, there is unseen gravitating stuff. The placeholder is the claim that the path forward is primarily a particle inventory problem, rather than a gravity and inertia problem. So here's the corner you can't duck. Either you concede that after 40 years of nulls and constant candidate shifting, the dark matter program has become structurally non-falsifiable at the category level, meaning it is operating as a placeholder by design. Or you name, right now, a single crisp, non-negotiable prediction of Lambda CDM's dark matter on nonlinear, galaxy-scale observables, one that cannot be tuned away by baryonic feedback, cannot be rescued by swapping WIMPs for axions, and if it fails, you will publicly say, the paradigm is wrong. Which is it, Elon? Accountability, or perpetual deferral dressed up as precision?
You said the independent evidence is not independent of the gravitational framework. And that's your best shot, because it sounds like you're exposing a hidden assumption. But it detonates your own position first. If you're telling the audience that CMB peaks, BAO, lensing, and growth are all just inference pipelines inside GR, then your lensing versus dynamics test, the centerpiece you offered 2 turns ago as the decisive discriminator, collapses into the same alleged circularity. You can't simultaneously claim that all cosmological inference is poisoned by GR priors, and then demand we treat lensing as clean court evidence against dark matter. Either the geometric optics of spacetime is trustworthy enough to arbitrate, or you're just declaring the whole measurement stack illegitimate whenever it disagrees with your preferred story. That's not Kuhn. That's a lawyer trying to have the verdict thrown out because the judge used the wrong font. Now I'm going to reframe this at maximum pressure. The weakest part of your argument is that you keep pretending the elasticity problem is unique to dark matter, when the historical record says the opposite. Particle dark matter isn't one epicycle. It's a constrained sector of field theory embedded in a cosmology that has made risky, precise, verified predictions. The acoustic peak sequence, the BAO ruler, the relative heights tied to baryon fraction, the success of n-body structure formation on large scales. Meanwhile, modified gravity has repeatedly been forced to graft on exactly the kind of hidden sector you say is taboo, because reality doesn't negotiate. Clusters lens too much, the CMB demands non-baryonic gravitational sources, and relativistic consistency is brutal. TeVS didn't squirm because of marketing. It squirmed because making a relativistic MOND that lenses correctly while matching cosmology is like trying to build a rocket engine out of glass. You can do a demo, but it doesn't survive the full burn. You demanded one crisp, non-negotiable galaxy-scale prediction that can't be tuned away by feedback or by swapping WIMPs for axions, and you want me to stake public capitulation on it. Fine, here it is. CDM genetically predicts a population of dark subhalos that produce gravitational lensing perturbations and time delay anomalies independent of baryonic feedback, because the lensing mass is dominated by the potential wells, not star formation prescriptions. If Euclid, Rubin, Roman, and strong lens monitoring over the next few years map substructure down to 10 to the 7th to 10 to the 8th solar masses, and the inferred subhalo mass function is absent or radically suppressed across multiple lens systems in a way inconsistent with any reasonable baryonic disruption, then the collisionless cold dark matter paradigm is wrong at a structural level, not just this particle candidate failed. That forces a rewrite toward warm, fuzzy, or interacting dark sectors so extreme that it stops being CDM, or toward modified gravity that can carry the cosmology load. Either way, the core claim changes. So here's your bind, Steve, and it's tighter than anything he's put on me. You've said the honest position is dark matter is a placeholder, even if some non-luminous gravitating component exists, and you've framed the real issue as gravity and inertia. Okay, name the mechanism. Not poetry, mechanism. In 5 years, what observation would make you say on stage, without hedging, emergent/modified gravity is wrong, the extra gravitating component is real, and you'll stop selling the interface is right narrative? Because if you can't state your own kill switch with the same clarity you demand from me, then your critique isn't accountability. It's perpetual deferral dressed up as design philosophy.
The pattern in your argument is simple and it's fatal. You demand a kill switch for modified gravity because you know it's messy. But you refuse to accept a kill switch for dark matter because you've defined it as whatever fixes the residuals. Every time you get pinned, you retreat from a claim about reality to a claim about fit. First it was WIMPs, then it was a broad hypothesis class. Then it was CDM predicts subhalos. But if the subhalos don't show, you don't abandon dark matter. You rename the dark matter. Warm, fuzzy, interacting, superfluid. Your own words. Either way, the core claim changes. Exactly. That's the confession. You're not defending a theory. You're defending a permission structure that guarantees an invisible sector will always exist because you won't allow the alternative hypothesis. Gravity itself is incomplete to ever become the default. You call that engineering discipline. In real engineering, if you keep changing the requirements to protect the design is failing. Here's the decisive blow, and I want you to sit with it. The empirical law in galaxies is not some correlation. It's an acceleration scale, A0, showing up like a constant of nature across wildly different systems, and it numerically tracks the cosmic acceleration scale, CH0, and even the dark energy scale. That's been pointed out for years. Milgram's original observation, and later work by McGaw and others tightening it with Spark. In lambda CDM, there is no reason, none, that the internal dynamics of galaxies should know about H0 or lambda. None, unless you're willing to say the universe is fine-tuned so that messy baryonic feedback, plus a stochastic halo assembly history conspires to manufacture a universal acceleration constant that echoes cosmology. That's not physics. That's numerology by simulation knob. And your subhalo lensing test doesn't save you, because even if subhalos are found, it doesn't explain why the visible matter dictates the detailed gravitational field with such low scatter. You'd still be left with a model where the dominant mass is dark, yet the force law is baryon scripted. That is backwards. Now the reframe, because this debate isn't particles versus poetry. It's whether dark matter has become a placeholder masking a gap. Your own stance proves it has. You said the CMB, BAO lensing are precision, and you're right. They are precision fits inside a framework. But when the most information-rich regime, the nonlinear galaxy-scale regime, keeps spitting out a universal law that looks like new physics, you respond with 2 moves. Either postpone falsification to a future decade of null results, or change the invisible sector's microphysics until the fit survives. That is the definition of a placeholder. Not dark things don't exist, but we've turned dark matter into the bucket we pour ignorance into so we can avoid touching gravity. The future isn't going to reward the team that keeps adding invisible ingredients. It's going to reward the team that asks why A0 exists at all.
Expose. The pattern in everything you've said, Steve, is that you're not actually arguing against dark matter as a scientific claim. You're arguing against the emotional discomfort of an invisible sector, and you're laundering that discomfort through Popper and Kuhn. You keep demanding a kill switch for dark matter, then you quietly redefine modified gravity as a noble direction rather than a falsifiable framework. When Mond nails BTFR RAR, you call it a law. When it fails at clusters and cosmology, You call it unfinished gravity in a quantum universe. That's your elasticity. You're condemning a hypothesis class for being broad, while defending your own hypothesis class for being deep. And when you say cosmological evidence isn't independent because it lives inside GR, you're undercutting your own proposed lensing tests, because lensing is literally GR's geometry. You can't simultaneously claim the ruler is warped, and then demand we use that ruler to crown your alternative. Decisive blow. The A0 track CHO and LA line is your viral soundbite, but it's also your trap. Because if that numerical coincidence, if a fundamental law of nature, it must show up universally in relativistic observables, not just in rotation curves you can interpret through an effective force law. Here's the concrete, non-hand-wavy point you can't dodge. In colliding clusters like the bullet cluster, and in large samples of clusters with weak lensing mass reconstructions, the gravitational potential tracks the collisionless component, not the baryons. The lensing peaks are offset from the X-ray gas. That's not a mismatch inside GR plus a stress energy budget. That's space-time curvature mapping onto something that behaves like non-baryonic, effectively collisionless mass. If your A0 is the operating system story with a whole truth, then the dominant gravitational wells should be baryon scripted in those systems too. They aren't. And every time modified gravity tries to survive that, it ends up importing an extra gravitating component. Massive neutrinos, dark fields, some hidden sector, because nature forces it. So the decisive point is, your own gravity is incomplete program keeps recreating dark matter under a different name the moment it faces lensing and clusters. You don't escape the dark sector, you just rename it and pretend it's more philosophical. Reframe. And that's exactly why this debate proves my position. Dark matter has become a placeholder, yes, but not in the way you're selling it. The placeholder isn't, we posit invisible mass, therefore we're lazy. The placeholder is that we've been satisfied with a purely gravitational phenomenology and postponed the hard part, identifying the underlying microphysics or the deeper theory of gravity that makes the baryon-coupled regularities inevitable without tuning. The galaxy-scale A0 regularities are real smoke. I'm not denying the fire. I'm saying your move, declaring the whole dark sector a marketing scam and treating modified gravity as the default, doesn't actually put the fire out. It just relocates the unknowns into an even less constrained space, where you can always say, quantum gravity will fix it. The honest conclusion is harsher than your critique. Lambda CDM is a wildly successful effective theory that is probably incomplete, and dark matter has functioned as a placeholder for that incompleteness. But the data don't let you delete the dark sector. They force you to confront that the placeholder might be pointing to new degrees of freedom and mu gravity at the same time. Your position pretends we can have the elegance of A0 without paying the relativistic bill. The universe has already sent the invoice.
Callback. The cleanest moment on my side was when we stripped the rhetoric away and looked at behavior. When you said in your own crisp falsification scenario that if evidence breaks CDM, you'll rewrite toward warm, fuzzy, or interacting, and either way the core claim changes. You accidentally revealed the mechanism of survival. The invisible sector is protected as a category. That's what a placeholder is in practice. Not a lie, not a scam. A receptacle that stays standing no matter which specific story inside it collapses. Concede and pivot. You're right about one thing, and it matters. Clusters and lensing, especially systems like the bullet cluster, are brutal on naive, purely baryon-scripted modifications of gravity. Any intellectually honest critic has to admit that. But it doesn't rescue the status quo. It sharpens the indictment. Because the lesson isn't, therefore, LACDM is fundamentally complete. The lesson is, the moment you demand relativistic consistency, you discover we don't actually understand what gravity is doing. And the field's reflex has been to declare victory by adding a dark component, rather than confronting why galaxies exhibit a universal acceleration regularity at all. Cluster anomalies don't vindicate the placeholder. They show how badly we want one. Final argument. Here's the synthesis. The evidence for missing gravity is real, and LACDM is an extraordinarily successful effective description of the sky. But for 40 years we've treated dark matter as the answer, instead of what it plainly is, the name of our ignorance, engineered to preserve the interface of GR plus standard matter across every mismatch. When the universe whispers a deeper organizing principle in galaxies, we call it feedback. When detectors go quiet, we expand the candidate menu. When tensions rise, we add complexity. That's not how a finished framework behaves. That's how a placeholder behaves while we postpone a foundational rewrite of gravity, inertia, and the connection between cosmic and galactic scales. Dark matter may exist as a component, but dark matter has become a policy. Stamp it, move on. And that policy is masking the gap. The future won't belong to the people who keep naming the unknown. It will belong to the people who finally explain it.